Hey there everyone, hope everyone's doing good. Today we're going to talk about class and instance variables. We've already seen the instance variables, we haven't seen class variables yet, so I want to bring those up, talk about the differences between the two and some things you need to be careful with when you're working with class variables. Here's the sources for this. You got GitHub code, I'll bring that up in a second. And then the Python documentation on classes. Again, I'd highly just recommend the python.org official Python documentation. You can find all sorts of stuff written up on all sorts of various websites around the web, but hey, this comes right from python.org, so you know it's legit. And they have great documentation. So I'll be referencing this as well. So the GitHub is right here, the Python repository here, and you go down here for video 3. And here's the student.py. I'm going to be working with this code at the end of the video. So we don't need it now, but it is here if you need it. And you can always go up here, click raw, and just copy and paste that into your text editor if you want. Other than that, I'll be working over here. This is a Python official documentation on classes and instance variables right here. So I have some screenshots here, and we're basically going to talk about this concept. But if you want to read more in depth, I highly recommend you just come here and go straight to python.org and read all about it. All right, so we've seen variables, right? And just normal programming, back when we were doing basic programming, we saw variables all over the place. We've seen instance variables so far. And we talked about those in the student class that we did in the last video, right? A student has a name, an age, a student ID, a courses. These are variables that are unique to individual instances. So if I change Jane's student ID, it doesn't change Joe's student ID. So I can alter the state of Jane's instance variables without changing the state of Joe's instance variables. And that's what this second bullet down here says, is it basically just says instances can have variables that are unique to that instance. Okay, those are created inside the init constructor. This is super important here, inside the init constructor. If you declare variables outside the init constructor, then they are class variables right up here. So classes can have variables that are shared between all instances of the class. Okay, these are created outside the constructor. Usually they're just under the class definition. There's many reasons you would do this, right? They just have shared commonality, but you can't get into an instance, or you can't get into a situation where, because the individual objects, the individual instances of the class have access to these class variables, they can also change them. So you can get into a situation where you can change an object A and it alters the state, basically, of object B. We'll see that in a second. All right, so most people, and you're going to hear me say this a lot, they just basically, interchange the term properties and attributes for these. Technically, they're different. A property is technically different than an attribute, but we're not really going to get into that. That's kind of some finer level programming stuff that maybe when we get a little bit more advanced in our object-oriented programming, we can talk about. But even at like the professional production level, I can tell you, for the most part, 99% of people are just going to interchange properties and attributes with variables. So I may say an instance variable, I may say an instance attribute, an instance property. They basically, in almost all cases, mean the exact same thing. So here is an instance, this is right from the python.org documentation. This is a class variable. Notice it's outside of the constructor. So here's our constructor here, and our class variable is outside of it. It's normally just underneath the class definition. So you'll have the class definition here, followed by normally a blank line, followed by a bunch of whatever you need for class variables. And these are shared by all instances. Then down here in the constructor is where you define your instance variables. They're unique to each instance, and that's where that whole self parameter comes in. Self is going to point to the object that's being created, so we're going to assign the dot name on that object itself. Whereas kind up here is being initialized on the class itself. A little confusing at first, much easier to understand when you work with it. You can see down here they create two dog objects. You have the D object, which is a dog with the name of Fido, an E object, which is the dog with the name of Buddy. You can access the kind, right? So D.kind is pulling from that class variable. It's shared by all dogs, and that's why it prints out canine. We can do the same thing. E.kind is referencing the same property, or excuse me, see, I just did it, right? It's referencing the same class variable, and that's why it's referencing canine. But notice, kind is not defined inside the constructor, so it's a class variable, not an instance variable. So if I change the value of kind, it's going to change it for both of these objects. And I'm going to do that when I start programming. And then all they do down here on these next two lines is say, hey, each one of these objects has their own variable, instance variable name that's unique to each one of those. So this is the example I have that I'm going to be programming. I have my student class, all right, class student. Okay, I have a class variable that's going to track the number of students that exist, student count, okay? Again, it's outside of the constructor, and it is underneath the class definition. That's normally where you're going to find them all. Then I have my constructor, and I didn't really change anything here in the constructor. At least in the parameters and the instance variables, they all have the same as the previous video. They all have a name, an age, a student ID, and a courses instance variable. However, I did at the end down here say at the end of running the init method, because we know the init method is going to be ran every single time an object is created. So if I'm going to run it every single time the object's created, that's probably a pretty good area that I can just go ahead and increment or add one to that student count. But notice what I have to do. I have to reference the class itself first. So there's that dot notation, right, with the little period there. So I have to say, go into the student class, which is up here. Get me what's in the right, on the right side, which is the student count, which is right there, and then set it to 1. So I can't just do, I can't forget this. So I can't just, say, remove that and just say student count plus equals 1. I'll show you why in a little bit. It's just going to give me a syntax error that doesn't exist. Or probably an attribute error, but whatever. And then not many changes here. So we'll just go ahead and jump right into the code and we'll play around with it. All right, back here in PyCharm, I have the student class we worked with in the previous video. It's nothing more than a class that represents a student. Each student has a name, an age, a student ID, and a list of courses for which they're currently registered for and attending. Only things I added was I now created a class variable. Remember, class variables are shared across all objects. So I created a class variable called student count, which is going to count the total number of students I should have created in my program. The way I'm going to do this and increment this every time I create a student is, well, let's think about it. Do we have anything that runs automatically anytime a new student object is created? Yes, we do. The constructor is ran every single time a new student object is created. So at the end of the constructor, I can just go ahead and reference that class variable and increment it. Now I have to reference it on the class itself. So you may kind of want to just do this, the student count, and you're going to say, well, it's defined up here, so I can just reference it. You're going to get probably an attribute error or value error. Let's see what happens here. It's because I'm not actually printing anything or calling that function, so let's try it again. Here we go. Unbound local error is what it is. All right, so the local variable student count, reference before assignment. It's on line 23 in the init method, the constructor. So here's my init. Here's line 23. That's just saying that local variable student count is referenced before assignment because it's looking for it in the local scope, so it's only looking inside this function. I have to tell it look outside the function. And where does it live outside the function? It lives in the student class. So that's why you do student dot student count. And remember, right, dot notation, go into what's in the left, get me what's in the right. And then we're going to add 1 to it. So every time I create a student, I should have all these instance variables that are unique to the student. I can change it in student 1 and it doesn't change anything in student 2. And each student is also going to have access to the class variable defined up here, the student count. So let's use our debugger and let's just step through one of these just to kind of get an idea of what's going on. And then we will go to the terminal. All right, so we'll debug. All right, so I've created in my special variable. So in memory, here's my student class itself. It's got student count, which is set to 0, which makes sense because I haven't executed line 26, so I haven't created any students yet, and this is the actual class. Okay, so your classes that you define will show up under special variables. I'm going to increment or resume my program. It should step up here inside the constructor to line 16. Why? Because I'm creating a new student object, and I know the init constructor is going to run every time I create a new object. So I advance, and here we go. It jumps up to line 16. It has not executed line 16 yet. So if I go down to this property self, notice it's already got access to the student count. So when you create an object, it is already getting access to all your class variables. Okay. It does put them on the object itself, so I do reference in from the individual's object, which is a little confusing, but it'll be a little bit more clear here as we progress. Now all of these are going to be instance variables, meaning that I can change it in this object I'm creating, and it's not going to change them in any other ones. As I step through this, you should see all these name, age, student ID, and courses get tacked on underneath this self right here. Okay, there's name, there's age, there is student ID, and we're going to come down here, we're going to break here. It hasn't executed this line right here. I want to show you something. I'm going to jump back into special variables. It did jump ahead already. Whoops. No, it hasn't yet. I'm going to increment. And now on the actual class, all right, this is the actual class I'm looking at. That student count is now equal to 1, which makes sense. We incremented it there. I can look at my Joe object, which now exists in memory because this side of the assignment operator executed, and then it assigned it here to the Joe variable, which stored it in memory as Joe. So now Joe also has student count equal to 1. Okay, Joe also has age, name, courses, all that stuff that was in the constructor, the instance variables, but also has access to that student count. So now let's just kind of get rid of these debug statements. Let's look at this in the terminal and see what we get printed out to the screen. Okay, we created Joe. Right, on this line, we printed that created Joe on this line. Right here, we're saying printed, or excuse me, Joe.student count is equal to Joe.student count, and the total student count is equal to, that's a little bit of an error. I don't want to access the student count variable from the Joe object. I want to access it from the class level. Just to show you that they're the same. Even though you're using the Joe object to access that student count class variable, so the individual instance objects have access to your class variables. However, it's going to be shared. The value of this is going to be shared amongst all your instances. So let's run this again. Okay, that worked. So now let's go down here and let's do it with Jane. What just happened? There we go. All right, so now we're saying, hey, Jane, we're creating a new student object. We're assigning it to the variable Jane. We're going to print out just a little separator line here. And then we're going to figure out what Joe's student count is again. It should be 2, right? Because remember, we're accessing a class variable that's shared among all instances. So Joe and Jane should have a student count of 2. And again, our class level student count should be 2 as well. Okay. So while you can access these class variables at the individual object level, you're really accessing some property that's shared among all of your objects. You can also update it manually. So I can also go into the student class itself and access that variable. So I can increment it without creating a brand new student if I wanted to. And let's run that and let's see what that gives me. So this is right here. So I manually change the student count. Joe's student count is now 3. Jane's student count is now 3. And when I access it at this class level, the class level variable is also 3 again. So even though these are class level variables, you can access them from the individual object itself, and you can access it from the class itself, and you can update it from the class itself as well. So could be a little weird here because now I have 3 students so that my program says exist, but I actually only have 2 that I've created. So you can get yourself into a little bit of trouble depending on how you program things if you don't keep them in the correct state at your programming level, because this doesn't kick out any syntax errors. This is completely legal to do. But that's a good little primer on instance versus class variables. Remember, instance variables are unique to individual objects. So if I change Jane's age, it's not going to affect Joe's age. Instance variables are done in the constructor, and you have to use the dot notation and reference this self. Because remember, that self is going to point to the object we're creating. Class variables are defined outside of the constructor, normally right underneath the class definition. What I mean by that is normally you wouldn't see something like this where you have your constructor and then underneath the constructor. It's still outside of it, right? It's not indented underneath it. But you normally won't see it this way. You'll normally see all your class level variables at the top underneath the class definition, followed by your constructor. Let's see, deciding between class and instance variables, all you got to do is think, is this something that's completely unique to an object? Do I want to be able to change it? If I change it on object A, should object B reflect any of those changes? If the answer is no, right? Which makes sense for ages, student IDs and stuff for my students. If the answer is no, then it's a instance variable. If the answer is yes, it's something that needs to be shared or tracked across all objects, then it needs to be a class level variable and defined outside of the constructor. So let's see, I think that's basically it for this video. In the next video, we'll probably talk about methods, so how I can do class or instance methods. We'll start with instant methods first, and then we can bump it up to class and static methods. All right, thanks for watching.